Hello students, myself Dinkar Satunkar again welcomes in this part 13 of chapter motion of 9th class physics. In this particular part we are going to derive the third equation of motion with the help of graphical representation. In the previous video I have explained you that how the two equations of motion, that is first equation of motion and second equation of motion, can be determined with the help of a graphical representation. Let us recap the previous two equations of motion so that we will link the third equation of motion with the help of this graphical representation. I told you that the graphical representation, the three equations of motion, can be determined with the help of velocity and time graph. So we have determined the first equation of motion with this velocity and time graph, where we have shown that the object started its initial velocity with u, and when it reaches to the final destination the object has the final velocity v. So with the help of this velocity and time graph we have successfully determined the first equation of motion, which the first equation of motion is very well known with this particular equation, that is v is equals to u plus at. This is called as the first equation of motion. We have determined this first equation of motion with this velocity and time graph. While discussing the derivation for the second equation of motion, the second equation of motion is also determined with the help of velocity and time graph, but by calculating the distance covered by the object with the help of velocity and time graph, we have calculated the second equation of motion. First equation of motion is determined with the help of slope of the graph, that is nothing but the slope of this AB line or this AB segment. We have successfully determined it with the help of acceleration, with the help of this slope, that is called as an acceleration. So we know that from this velocity and time graph the slope of this segment, that is the curve of this AB, is determined the quantity, that is nothing but the acceleration. So with the help of acceleration we have later on determined the first equation of motion, that is v is equals to u plus at. Now we very well know that the area under this curve, particularly for velocity and time graph, gives us the distance traveled by the object. So with the help of distance traveled by the object, the area under this curve gives us the very much shape, that this shape is called as the trapezium. And with the help of the area of the trapezium, with the help of this rectangle and this triangle, we have successfully calculated the distance covered by the object. That distance covered by the object is nothing but this s is equals to ut plus half at square. So this is our second equation of motion. With the same velocity and time graph we will be going to determine the third equation of motion. So for third equation of motion also I am referring this particular graphical representation. So keep in mind this particular diagram that gives us the third equation of motion. Let us try to calculate the third equation of motion with again the velocity and time graph, but at this time I will be dealing this third equation of motion with a different kind of treatment. So the previous diagram that we have seen is the velocity and time graph. This diagram is also same, but I have drawn this diagram in such a way that we will get a geometrical shape, that is nothing but trapezium. So again for third equation of motion also we are considering the same scenario, that object is moving, and while the object has started its motion the initial velocity is nothing but u and the final velocity is nothing but v. When object reaches from point A to point B, the object, this particular motion has completed in time t. So when it reaches at this point B, the time completed by that object is nothing but t. So this is nothing but the time axis and this is nothing but the velocity axis. Now I will be taking help of this shape A, B, E, O. This particular shape I have drawn it separately so that the students can easily understand. that what is this shape look like and what this shape is called as. This shape is called as a trapezium. Trapezium is this particular shape which is represented by A, B, E, O. Let us try to understand some specialities of this shape trapezium. Now this trapezium consists of two parallel lines. Here OA and EB or PE, these are the two parallel lines. The remaining two lines are not parallel, amongst which AB is an inclined line and OE is nothing but an horizontal line. So here the area of the trapezium can be calculated with the help of these parallel lines as well as this particular horizontal line OE. The two parallel lines are nothing but OA and EB, while this OE line is, which is the exact perpendicular line to this OA and EB, which is joining these two parallel lines, is called as the height of the trapezium or distance between the two parallel lines. Why I am telling you? Because we are going to take the help of these concepts of the trapezium to calculate the third equation of the motion. Now while discussing the third equation of the motion, we know that the velocity and time graph, with the help of velocity and time graph we can calculate the distance covered by the object, or we can say that the area under this curve gives us the distance traveled by this object. So area which is enclosed in this region O, A, B, E, O, if I can calculate this particular area, then this area will give me the distance covered by the object. So now I will place the equation for the distance traveled by the object, and this distance traveled by the object I can know it distance traveled S is equals to area of this particular shape, that is nothing but O, A, B, E, O. Now this particular shape is nothing but trapezium, so I will write here as distance traveled S is equals to area of the trapezium A, B, E, O. I have drawn this trapezium separately here also. Now the formula for the area of the trapezium, with the help of this very much lines which are included over here, amongst which OA and EB are two parallel lines to each other, while OE, this particular segment, is joining between the two parallel lines OA and EB. So I will be taking help of these particular segments of the trapezium over here. I know that area of the trapezium is nothing but half into sum of the parallel sides multiplied by the height. I told you that OA and EB are the two parallel sides and height is nothing but this particular line or segment OE which is joining between the two parallel lines. So this is called as a height. So I have to take the sum of the parallel side, that means nothing but these two parallel sides OA and EB. I will be taking the sum of these two parallel sides of the trapezium and I will place those two sides sum at this particular position, and height is nothing but this particular OE. So the same formula in this particular trapezium's segments I can write 1 by 2 multiplied by one side is nothing but this AO, so I will write here as AO, plus this second parallel side is nothing but this BE, so I will write here as AO plus BE, because I am interested in taking the sum of the two parallel sides. So AO plus BE is nothing but the sum of the two parallel sides. Now what is the height? I told you that the distance between these two parallel lines, or the line which is joining between the two parallel lines, which is called as the height of the trapezium. So this is nothing but this particular segment OE, so I will write here as this is nothing but OE. Now what is this OA, what is this BE, and what is this OE? I will place the values of this particular segments while considering this velocity and time graph. So what I can write for this AO or OA? Now if you look carefully, this segment in this velocity time graph is nothing but OA. Now initially the object's initial we can say that the motion is at zero initial position, that is nothing but O, object has started the motion A, where the initial velocity is nothing but u. So OA or AO, this particular segment, gives me the difference between the velocity, that is nothing but magnitude of this velocity, initial velocity u, and this 0. So I will take here u minus 0, that is nothing but u. So instead of this AO, the magnitude of this particular segment OA or AO, I can write u. While if I go on calculating this BE, now the final velocity at this point B, the magnitude is nothing but v, and initially the 0 point is there. So difference between B and E, that is nothing but v minus 0, will give me the v. So that's why instead of this v, I will write here v. What is this segment OE? OE is nothing but the time from O, that is initial point 0, to the t, that is nothing but difference between these two times. So t minus 0, or merely we can call this as OE, is nothing but t. So if I reshuffle this equation, if I do the rearrangement to this equation, this I can write is as u plus v divided by 2 multiplied by t. So now the distance traveled s is equals to u plus v divided by 2 multiplied by t. I will call this as equation number 1. Moving little bit ahead, I know that from the same graphical representation we have also determined the first equation of motion. Now what is that first equation of motion? I know that from first equation of motion we can write v minus u is equals to at. If I rearrange this equation, because I want the value to be determined from this equation is nothing but the value for the t, which I can place in this equation number 1. So if I transform this equation in terms of t, then I can get t is equals to v minus u. This a is in multiplication, is at this side. When it goes in this side, it goes in the denominator. So t is equals to v minus u divided by a. What I will do now, I will place this particular value of t in this equation 1. So if I substitute this value of t in this equation 1, the equation will become like this. S is equals to, this part is same, u plus v divided by 2, but for this t, now I can write v minus u divided by a. So u plus v divided by 2 multiplied by v minus u divided by a. Now if I rearrange this equation, because in denominator now you can see here this is 2 and this is a, so I can multiply it. 2 multiplied by a will give me 2a. If I take this 2a value at this particular side, then the equation will become as 2a into s is equals to u plus v into v minus u. Now if you look carefully, this particular value of v plus u, one bracket, and in second bracket v minus u, then you will see that this is nothing but an expansion of one of the formula that we have seen, that is a square minus b square, which gives me a plus b, a minus b, in bracket one bracket a plus b, in second bracket a minus b. In similar way, you are seeing that here v minus u and v plus u, or you can write u plus v, this is nothing but the expansion of v square minus u square. Like we have constrained these two brackets in one bracket, that is a square minus b square. So I can constrain these two brackets in the form of v square minus u square. So now the equation will become as 2as is equals to v square minus u square. If I convert this equation in the form of velocity v, then I can write this as 2as is equals to v square minus u square, which after some rearranging in the form of the v, velocity v, I can write this equation as v square is equals to, if I take this u square in this side, this minus u square will become as plus u square. So that's why this equation will become as v square is equals to u square plus 2as. Now this equation and this equation, you can keep any of the equation as the third equation of motion. Both these equations are called as the third equation of motion. Now this third equation of motion, since this particular equation gives me the equation for the velocity, that's why the third equation of motion is also called as the equation between velocity and acceleration. So here either you can consider this as 2as is equals to v square minus u square, or you can consider v square is equals to u square plus 2as. Both these equations are called as the third equation of motion. So either you take the first equation of motion, or second equation of motion, or third equation of motion. All these three equations of motion are equally important. in numericals also. In many numericals where the values of velocity, initial velocity, final velocity, acceleration, or time period, or time, or distance covered by the object, all these three equations of motions are important. So here the equation for the third equation of motion, which is determined with the help of velocity and time graph, that is graphical representation, we have seen. In the next video we are going to see about a very important article from this chapter, the last article from this chapter, that is nothing but uniform circular motion. So keep watching the videos so that you will clear all your concepts. Thank you.